Hello. In this video, I'm going to give a quick walkthrough of the Scholar notebook of Numpy Foundations for Deep Learning. So, firstly, in this, we'll import the required library, that is Numpy as NP, and this cell talks about the matrix multiplication and how it works. So, if we take an array which is 3 by 3 matrix and like 3 by 2 matrix, so since the inner dimensions match here, then the output will be given. Because inner dimension matching is a very important factor for in inner rows matching is in inner dimensions matching is a very important factor for matrix multiplication. And we'll see how the output works here. So we'll take like a zeroth element of the output matrix, how it is calculated. We can see like there is like 1 cross 7 plus 2 cross 9 plus 3 cross 11, which is like rows by column of the A and B matrix, rows of 0, row 0 of A and column 0 of B, and the output is 58. That means the output element, 0th element of the output matrix has the value 58. So next one is here I create a matrix. Here we create a matrix A with a shape of 2 cross 3 and a matrix of with a shape of 3 cross 2. Then multiply them using the add operator. This is the add operator, and the result is a 2 cross 2 matrix. And I print all the three to show the input and the output shapes. Next is the neural network layer, which is z is equal to wx plus b. This cell simulates a real neural network layer using the formula z is equal to wx plus b. I create a random input data called x, and also weight w and also bias b, and then compute the layer output for a batch of 4 samples. Next is visualizing. Um, Here I visualize how broadcasting works using matplot library, and I plot the original matrix and the row vector and the result side by side. Here the result side by side to make the broadcasting concept easy to see. Next is matrix vector broadcasting. In this cell, I add a 3 cross 3 matrix, which is here with a 1D row vector. 1D row vector. Numpy automatically stretches the vector across the row of the matrix. This is broadcasting, and it is used constantly in deep learning. We can see the output here. Next is scalar and array broadcasting. This is the simplest broadcasting example, adding a scalar value which is 10 to every element of an array. Numpy internally stretches the scalar to match the array shape without copying the memory. And next is activation and function. This cell sets up and defines all the activation functions, which is sigmoid, tanh, relu, and leaky relu, and then uses mat plot library to visualize them. It's a reference cell used for plotting in later steps. And also we can see how the each function is plotted in a graph form. Next is implementing activation functions. Here I implement the 4 key activation functions using NumPy. Sigmoid, what it does is sigmoid squashes the value to 0 comma 1, and tanh, which squashes to -1 and 1. Relu does that to 0 comma x and respectively. And leaky relu allows only a negative slope. Next is essential math functions. So this cell demonstrates NumPy math functions like np.exponential and np.log, and that are the code to deep learning. Exponentials are used in softmax and sigmoid, and logarithms appears in cross entropy loss. Next is visualizing element-wise multiplication. I use a matplot library here to visually show how two arrays are multiplied element by element. This is one array and second one is this. Each corresponding pair is shown side by side, making the Hadamard product concept visually clear. This is the output. And next is element wise operation. This cell shows arithmetic between two same shaped arrays, and addition, subtraction, multiplication, and division. These element wise operations are fundamental in back propagation and gradient computation. Basic arithmetic on arrays. Here I show how NumPy applies arithmetic operation to every element of an array automatically, like adding, multiplying, squaring. All that happens without any loops, which makes it very efficient. Next is setting up the cell. This is all to set up the cell that imports NumPy, Matplot library, and other libraries needed for the notebook. I also configure plot style so all visualization looks clean and consistent. Next is 1D array vector. I create a simple 1D array from Python list and print its shape and dimension. Um, a 1D array is called a vector and is the most basic building block in NumPy. Next is 2D array, which is matrix. This cell creates a 2D array or matrix with a row of 2 and 3 columns. It prints a shape of 2 comma 3 and show it has like dimensions too, just like a table or spreadsheet. Next is 3D array, which is tensor. Here I create a 3D array also called tensor and print its shape as 3 comma 2 comma 2. In deep learning, 3D tensors are used to represent batches of sequences or grayscale image batches. Visualizing array dimensions. This cell uses bar charts and heat maps to visually represent 1D, 2D, and 3D arrays. It helps to build an intuition for how data is structured at each dimension level. We can see here. Next, zeros and ones array. I created arrays filled with zeros and ones using a z np ones and np zeros. Yeah, zeros are used to initialize biases in neural network and ones are used for mask and scaling operations. Next is ranges and line spaces. This cell demonstrates np.arrange for step-based sequences and np.linespace for initially spaced values. These are used for position encoding and learning rate schedule in deep learning. Next is data types. Here I create array with different data types, which is int 32, float 32, and float 64, and compare their memory usage. Float 32 is the standard in deep learning for balancing speed and precision. And then is visualize D-type memory. This cell use a bar chart to compare memory usage across float 16, float 32, float 64. It shows why choosing the right D-type matters for GPU memory efficiency in large models, as we can see in the output. Next is real deep learning tensor shapes. I create tensor matching real deep learning shapes like the MN is image batch and the RGB image batch. This shows how actual data is structured when fed into neural network. Next is visualizing an image batch. This cell stimulates and visualizes a batch of 10 fake MNIST like image using a matplot library. It shows how a shape like 10, 28, 28 represents 10 individual and 2D images. We can see those images here. Next is shape prediction exercise. This is a practice to predict the um, uh, exercise where I create arrays and predict their shape before printing. It reinforces understanding how zeros and ones and identify matrix are structured. Next is 1D indexing uh, arrays. So I access individual elements of 1D array here using both positive and negative values, negative indexing. Positive indices count from the start and negative indices count from the end of the array. Next is visualizing indexing. This cell draws a visual diagram of a 1D array with boxes showing both positive and negative index positions. It makes the dual indexing concept easy to understand at a glance. Next is array slicing. Here I demonstrate slicing a 1D array using start, stop and step values. I show how to extract the n elements, elements from a certain index and every other element. And here this cell will see how train or validation split works. This cell applies slicing to a real deep learning task, splitting hundreds of samples into a 80% of training and 20% of validation sets. This is a fundamental pre-processing step in every ML pipeline. Next is 2D array indexing. I access individual element of a 2D matrix using row and column indices. This is how we extract a specific neuron activation or weights from a layer in a neural network. Next is array 2D array slicing. This cell shows how to slice rows and columns and sub matrices from a 2D array. These operations are used to extract future maps or specific channels from image. Next is visualizing 2D slicing. I use heat maps to visually highlight which rows, columns and submatrices are selected during slicing. The highlight cells make it easy to exactly what each slice extract. Next is mini batch selection. This cell stimulates select a random mini batch from a data set of 1000 images. Mini batch selection using array slicing in a core step in training neural network. Next is Boolean indexing. I create a Boolean mask by checking which element are greater than 0 and then use it to filter the array. This is a clean way to select elements based on condition without loops. This cell implements the ReLU activation function using a Boolean indexing. All negative values are set to 0 and it shows how a real deep learning operation maps directly to Numpy. Next, here I use an array of specific indices to select non-consecutive elements from another array. This is called fancy indexing and is more flexible than basic slicing. The last one is word embedding lookup. This cell simulates a word embedding lookup. NLP operation gives a sentence to word indices. uh, I use a fancy indexing to retrieve the corresponding embedding vectors from the embedding matrix. So that's it with this. That's it with the demo of this notebook. Thank you.